Hi, today we're going to learn how to find the inverse of a matrix using the Gauss-Jordan method. This method is one of the applications of the elementary row operation. So to begin with, we have an example of a 4 by 4 square matrix. The first thing that we have to do is to write down an identity matrix whose size is equivalent to our input matrix. So in this case, we have a 4 by 4 matrix. Thus, we will have to write down a 4 by 4 identity matrix. So the basic idea is we have to make the input matrix turned or transformed into an identity matrix, and then while we perform the elementary row operations, we will also apply it to the identity matrix. Hence, the answer or the inverse of the matrix will then be turned out to be the transformed figure of this 4 by 4 identity matrix. And to make it more convenient, we will work by columns. So first thing that we have to do is to divide the first row, which is row 1, to the first element, which is equivalent to 2. As we divide the first row to 2, we will come up with a matrix 1, 2.5, 0.5, 1.5, 0.5, 0, 0, 0. And then row 2, since this element has to be equal to 0, what we're gonna do is to multiply the first row with 4. And then subtract it to the second row. This will result to 0, negative 8, 1, negative 8, negative 2, 1, 0, 0. We will be doing the same with the third and the fourth row. So row 3 will be equal to negative 3 multiplied by R1 minus R3, and then R4 equals 3 R1 minus R4. So this will result to 0, 8.5, 0.5, 6.5, 1.5, 0, 1, 0, 0, negative 11.5, 0.5, negative 5.5, negative 1.5, 0, 0, 1. So as you can see, the first column was achieved to be an imitation of an identity matrix. And then as we can see as well, the first column of the identity matrix was transformed into a different, transformed with different elements. So since we're done with the first column, we will proceed to the next column. This will provide us these equations. R2 is equal to R2 divided by negative 8 to make it equal to 1. And then R1 will be equal to 2.5 R2 minus R1. R3 equals 8.5 R2 minus R3. R4 equals negative 11.5 R2 minus R4. So as you can see, the elements of the second column are just copied in our formula. And then this formula will result to this matrix. As you can see, the first and the second columns are transformed as if it is a member of an identity matrix. And the first and second column of the initially an identity matrix was turned to have different elements. And the next thing we will perform with the third column. We have these equations. R3 is equal to R3 divided by 1.563, which is the element or the coefficient of the third row and the third column element. And then R1 is equal to 0.813 R3 minus R1. R2 is equal to negative 0.13 R3 minus R2. And lastly, R4 is equal to negative 0.94 R3 minus R4. Another thing, we have these coefficients just copied from these elements of the matrix. And then after we perform these formula, we will come up with this matrix. So as we can see, the development, we have the first, second, and the third columns turned into an identity matrix. So with that, we will have these equations. R4 is equal to R4 divided by 4.8, since the corresponding element of this matrix is equal to 4.8. And then R1 is equal to 0.04 R4 minus R1. R2 will be 0.84 R4 minus R2. And lastly, R3 is equal to negative 1.28 R4 minus R3. With that, we will come up with this matrix. So as we can see, the previously input matrix was turned into an identity matrix. Hence, the identity matrix on the right-hand side of the figure was turned into our final answer, which is the inverse of our input matrix. That would be all. Thank you.